In this video, we're going to be talking about a concept called the difference quotient. This goes hand in hand when we're talking about the composition of functions, but this actually is going to lead into a higher concept called the derivative. When you take calculus, the difference quotient is the quotient f of x plus h minus f of x, all divided by h. It's often called the difference quotient. This value is used in calculus operations. Actually, to work this problem, you're going to do 3 steps. You're going to find f of x plus h, which means you're going to put x plus h in for x in your original function. Minus f of x means you're going to subtract the original function from that. The third step, you're going to divide h out of what's left over. So this is just a 3-step process here of how you find the difference quotient. So find the difference quotient for the following function. We have a function here. It's a linear function. F of x equals 2x plus 4. So like I said earlier, we're going to do this in 3 steps. We're going to find f of x plus h. So first, let's do that. F of x plus h is you're going to say 2 times, instead of x, we're going to put x plus h in there, plus 4. Okay? So that's f of x plus h right there in that one step. Minus f of x. So minus f of x was originally this function 2x plus 4. And then that's going to all be divided by h. That's the third step. So all I have to do really to work this is do the algebra and work out the steps of it. So we're going to say 2 times x plus h. We're going to do the distributive property. 2x plus 2h plus 4. Okay, and then when I subtract, remember, I distribute the minus sign across the grouping symbols. So minus 2x minus 4. And then that's all divided by h. Now, if you'll notice in the numerator here, 2x minus 2x, those subtract away. 4 minus 4 also subtracts away. If this is done correctly, the polynomial here, when you subtract f of x, all of those terms should always drop out with subtraction. Always, every time you do this. So that leaves us on top with 2h, then divided by h. So as you can see, the h's cancel out and leave me the difference quotient being 2. So it's just a problem where you're doing composition of functions and you're going to do a lot of algebraic steps to simplify your situation. Now when you guys take calculus classes, you'll learn that this is the derivative or an equation that you can use to find the slope of tangent lines to this function at specific points on the function. Let's do another one. Notice it's the same problem, f of x plus h minus f of x all over h for a new function. This function is a parabola. Let's see how this works. So we're going to first find f of x plus h. So x plus h squared plus 2 times x plus h minus 1. Then we're going to subtract f of x. So minus, and I always put brackets here just to let me know I'm going to have to distribute a minus sign. F of x originally was x squared plus 2x minus 1. And then that will all be divided by h. Okay? So we need to work out the x plus h squared. You could write that down twice and do the FOIL method. Or you could square the binomial like we learned in earlier algebra classes. Square the first term, so x squared. Multiply the 2 terms together and double it. So x times h doubled would be 2xh. And then square the last term, so h squared. Then distribute the 2 times x plus h, so plus 2x plus 2h minus 1. And then distribute your minus sign across the polynomial. So minus x squared minus 2x plus 1. And again, this is all divided by an h. So on top, if you'll notice, you've got terms that are going to subtract away. X squared minus x squared. 2x minus 2x. Negative 1 plus 1. So every term that's left over, if you'll notice, has an h involved in it. So we're going to divide that h out. So I have 2xh plus h squared plus 2h, all divided by an h. So if I remove an h from everything, that would leave me 2x plus 1h plus 2. So there's your difference quotient. Okay, here's another function. I just want to work several examples of this problem so you'll kind of have an idea of what you're doing. So f of x plus h, we're going to have negative 3 times x plus h squared minus x plus h plus 5. Then we're going to subtract the original function, so minus f of x, so minus negative 3x squared minus x plus 5. And of course, that is all divided by h. Now, this time, I'm going to have to square my binomial, but I'm also going to have to multiply by negative 3. So we've got to do that step first. We've got to square our binomial first. We know that's x squared plus 2xh plus h squared. Remember, you get that by squaring the binomial or doing the FOIL method. So I'm going to write this down. Just a couple of little extra steps here. Okay, so we're going to do our distributive property. Negative 3x squared minus 6xh minus 3h squared. Okay, you got a minus sign in front of your x plus h, so I'm going to distribute that. Minus x minus h plus 5. Distribute your negative across the polynomial, so plus 3x squared plus x minus 5, and that's all divided by the h. So simplify the numerator terms. You've got the negative 3x squared, going to drop out. Negative x, positive x, 5, and negative 5. So what that leaves us, come over to the side here, that's going to leave us on top negative 6xh minus 3h squared minus h, and that's going to all be divided by h. So if I take an h out, that leaves me negative 6x minus 3h minus 1. For your difference quotient. So let's do one more example, a little bit higher order, see if that makes any difference. My function is just the x cubed function. We want to find the difference quotient for that. So we're going to do the same thing we did earlier. We're going to have our x plus h. So if this time that's going to be cubed. So then minus my original function, minus x cubed all over h. Now, later on in this pre-calculus course, you're going to learn how to expand binomials to powers of, 3 is going to be very mild. You'll do powers to the 5th, to the 6th. But for just time purposes here in this problem, I'm going to show you if you've multiplied x plus h times x plus h squared, that would be the same as x plus h cubed, right? So if I have x plus h times, we know that, it should be x plus h times x plus h squared. That would give me x plus h cubed. So we know that this is x squared plus 2xh plus h squared. So if you remember from earlier algebra courses, to expand this, you would multiply x times everything, and then h times everything, and then combine your like terms. So this would actually give me x cubed plus 3x squared h plus 3x h squared plus h cubed, and then minus the x cubed that you have, all divided by h. The only thing that's going to subtract away on top will be the x cubed terms. So if I take an h then out of what's left over, that's going to leave me 3x squared plus 3xh plus h squared as my difference quotient. Don't let the higher powers confuse you. It just makes the algebra a little bit more difficult. So you just multiply x plus h times all this, and that's what you would have gotten as your simplified or your expanded version.